So good morning one and all. So let us start today's class. In the last class we have seen a back propagation technique. So in this technique, as the name itself indicates, we move in the backward motion by tracing the nodes, and in that way we find out the weights or we update the weights. Okay. What is the definition of back propagation? So it's a backward movement through the neural network nodes to gauge how much each weight in the network contribute to deciding the overall loss function. Okay. So in this back propagation, we use a chain rule. Okay. Now, so this is a back propagation. This is a simple network. This is the output layer. This is the hidden layer. This is the input layer. Okay. So in this one, we have only one hidden layer with two neurons. These are the biases. So these are weights. Okay. Now, so here, so first of all, what you have done? These are the given values. So obviously we have a target. So first of all, we have to find out the predicted values. That is y cap. What is that? y1, y2. So these are predicted values, and we have true values or target values. So if they are not same, obviously it indicates an error. So if there are error, we move backward and we update the weights so that error is minimized. So this is the already for every neuron we have two parts. One is pre-activation and activation. Okay. Now we are calling as H1 is a pre-activation and H1 final as the activation. We are using the sigmoid function for the output layer. So I explained this problem in the last class. I hope you can go through it one more time. Right. So this is the chain rule for the univariate function. Okay. Now, so this is the problem of chain rule, and we are using what algorithm? Gradient descent algorithm. But in this we are using a chain rule to update the or to gauge the weights at each node. Okay, so this is how we do back propagation. So if I want dou L theta by dou W111, what do we do? We propagate in this way as a chain. First, what do we do? Dou L theta by dou y bar. Dou L theta by dou y cap. Next, dou y cap by dou A L11. Okay. So here actually, here I have written AL1. This is a vector actually. Okay. So it should have AL11, 1, 2, so many elements. Okay. Now here, so this dark green region is the activation, and dark light blue region is the reactivation. Here also this dark blue is the activation and light blue is the reactivation, so on so on. Okay. So what have we done? Dou L theta by dou y cap. This is the output layer. Dou y cap by dou A L11. Dou A L1 by dou H21. Dou H21 by dou A21, dou A21 by dou H11, dou H11 by dou A11, dou A11 by dou W111. So this is the comprised form of chain rule. What have you done? So from here to here we have come straight away. Next, here to here. Now, so in the same way, you can write for any other weight. This is a chain rule for finding the weight. So please remember, we are taken a deep layer. This is a single layer I have taken. Okay. This is a thin and deep network. So it may have multiple paths. Okay, we'll discuss that later. And this is the final chain rule for the any weight in the path. Now this is how it happens. First of all, we ask for the output layer. We check the output layer. If everything is fine, we go to the first hidden layer or last hidden layer. So in that way we move. Next, we check all the weights and we move in the backward direction like this. First, we are going from here to here up to output layer. Next, in the next iteration, we will go for the last hidden layer. We check all the weights. Next, we go to the first hidden layer. Finally, we go to the input layer. This is how the back propagation works. Now, this is the simple thing. First, so talk to the weight directly. So, I want to find out what is the contribution of this weight in the loss, which means dou L theta by dou W111 let us take. Okay, well, first what do we do? First, we ask the output layer, which means dou L theta by dou y cap and dou y cap by dou A3. Talk to the output layer. So, if everything is fine, we go to the hidden layer. So, what is hidden layer? Dou A3 by dou H2 by dou A2. Okay. Yeah. First, we talk to the output layer. This is output layer. What is the output? Y cap or Y hat. What do we do now? Dou L theta by dou Y hat into dou Y hat by dou A3. Because in this layer, in this neuron, what is the activation? Y cap. What is pre-activation? A3. Next, here. Okay, what do we do here? So, dou A3 by dou H2 and dou H2 by dou A2. Okay, this neuron. Next hidden layer. Dou A2 by dou H1, dou H1 by dou A1. And finally, in this, we are interested for this particular weight. So, dou A1 by dou W111. So, in this way, we can find out the contribution of any weight to the loss function. So, we move in this backward direction. Okay, now. So, this is how the algorithm works. What algorithm? Back propagation. First, we have to find out the gradient with respect to output units and with respect to hidden units and with respect to weights and biases. As I told you just now. Okay, first we need to find out the gradient. What is gradient? This one. With respect to what? Output units. Which means, what are they? AL. Here what is the? Here L equal to 3. That's why we have a A3. A3 is a vector. Why? Because what is A3? Generally, this is A3 means what? 1, 2, so on, so how many? K neurons. In the output layer, we have K neurons. A3 is the pre-activation of output neurons. So we have A31, so A32, so on, A3K. A3 is a vector. Generally, is a vector. Okay. So we talk to the output layers. We have to find out the gradient with respect to the output layer. Next. So gradient with respect to hidden units. What are the hidden units? These two. So hidden units means what? H2, A2. Okay. So we have to find out the gradient with respect to the hidden units. Next, finally, we have to find out the gradient with respect to the weights and biases. W and bias means B. Okay. So what is the gradient? I told you already. Gradient is the what? Partial derivative of all the elements of a vector. It contains partial derivatives. Okay, so first let us go with the gradient with respect to the output units. First of all, now this is the last function. Let us take, what is this actually? This is the cross entropy, that is minus YL. Now what we have added this activation. What is the output activation? Y cap. What is the y hat? Y1 hat, so to so on, yk hat. So at this output layer we have y hat. Okay. Now, so log of YL hat. What L gives the true class label. Now y hat is the all the combinations of predicted values. Actually, what is y hat? It is the distribution of predicted values. What distribution? Probability distribution. Okay. So first I want to find out the gradient of the output layer. Okay. What output layer? Y cap or y hat, both are okay. So which means I want to find out dou L theta by dou yi cap. Okay. Okay, what next? Okay, so but L theta is the what? Minus log YL hat. Okay, now this is what we have to find out. You know already. So please remember, we have dou log minus is this side YL cap by dou yi cap. Here in the denominator we have a index I, in the numerator we have index L. Okay, so obviously there is only one true class. You know already classification. We have to find out true class out of k classes, 1 out of k classes. Obviously, what is the derivative of this? Log x, it is 1 by x. Okay, so here what is the derivative of minus log x? Minus 1 by x. But please remember, it is true if and only if I equal to L. Isn't it? If I is not equal to L, obviously 0. Why? Because we are differentiating true class with a wrong class. Okay, so please make a note of this. So this is very, very important. A simple differentiation of logarithm, right? So this is simply denoted by this symbol. So please, this symbol is called indicator symbol. What symbol is called? Indicator. Okay. What is the meaning of the symbol? If the quantity in the brackets is satisfied, it is 1. Otherwise, it is 0. Okay. If I equal to L, 1. Then what happens now? Minus 1 by YL hat. If I is not equal to L, this is 0. Same thing. So the same thing is being written using this indicator variable. Is it okay? So please remember this. It is something like this. 1. If I equal to 1. If I write like this means, if I equal to 1, the output is 1. Otherwise, output is 0. Correct? So remember this variable is very, very important. Now, so simply what I have done is, till now I got what? Dou L theta by dou yi hat. What is this? Indicator variable. I equal to L by YL hat. This is minus. If I equal to L, it is minus 1 by YL hat. Otherwise, it is 0. So, but here, if you remember, this is only with respect to yi hat. But what is y cap? What is y hat? It is the combination of several elements or quantities. What is this? y1 cap, y2 cap, yk cap. So we want to have a del or gradient of the what? I want gradient of y cap itself with respect to loss function. But y cap is a vector of k elements. What are they? y1 cap, y2 cap, so on, so on, yk cap or yk hat. So as I told you, gradient means you have to take the partial derivatives. It is a combination of partial derivatives. So what I do? Dou L theta by dou y1 cap, dou L theta by dou yk cap. Okay, because it has got k elements. So already you know from this equation, what is dou L theta by dou y1 cap? Okay, dou y1 cap. What happens now? Here I equal to 1. That's why L equal to 1 by L cap. Okay, so we get the combination of indicator variables just like this. This is only for one element. It is only for one element. Okay, it is only for one element. You can implement this for k elements. Suppose if I say from this equation itself, if I ask you what is dou L theta by dou y1 cap, so I equal to 1, then what do you write? Minus I L equal to 1 by yl cap. If L equal to 1, what would happen? Minus 1 by y1 cap. If L is not equal to 1, it is 0. So we are writing for all k elements of a vector y cap. So this is what you get. Now what is EL? Okay, one more thing is, so since L is a true class label, only one of them is 1, remaining are 0, right? Suppose only one of them is a true class. Suppose you take k classes. So if you want to find a true class, obviously only one of them is 1, remaining are 0. Are you agree with me or not? Okay, because if at all you want to find the true class among the k classes, only one of them will be true class, remaining are not. So one, at least there is 1 and remaining are 0. Okay, obviously, so this is called EL. This vector is called EL vector. Is a k dimensional vector whose lth element is 1 and all elements are 0. If the first is a true class, what happens? The first one will be 1, remaining are 0. If the second class is a true class, second element is a 1, remaining are zeros. Isn't it? Okay. So now this is a one hot vector. What is called? One hot vector. Because only one of the elements is 1, remaining are 0. Anyway, so this is the, what is the, finally this is the gradient of the output layer. Okay. Next, so which means you have done with the gradient of what layer? Output layer, that is y cap or y hat. Next, we have to find out the gradient with respect to hidden units. All these things. Okay. Anyway, sorry. We have to find out this one also, right? In the output layer, we have activation, pre-activation. We have done with the activation. That is a dark green region. What is a dark light green region? This is A3. Generally, that is AL. Okay. So we are finding dou L theta by dou ALI. As I told you, A3 is what? Combination of all these K light green regions that are pre-activations of the K neurons. Okay. Otherwise, let me write here. So in the output layer we add k neurons. Okay, each neuron is divided into two parts. This is called activation, this is called pre-activation. So what is the activation output? Y1 hat here, Y2 hat here, Yk hat. Pre-activation, actually this is combinedly called as Y hat. Now here what is happening here? These are combinedly called as AL, the pre-activation, but this is AL1, AL2, so on, so on, ALK. This is nothing but what layer? Output layer. Please remember. In the output layer we have how many neurons? K neurons. Okay. Now here we have to find out with respect to what? AL1. Otherwise simply LI. LI can be any value between 1 to K. But what we can do? What do we do first? So how to find out this now? So here we have two parts. This is YL hat, this is ALI. So using the I want dou L theta by dou ALI. How to find this? Chain rule. First find out this is L theta. First L theta of YL cap and YL cap by ALI. That is chain rule, right? So dou L theta by dou YL hat and dou YL hat by dou ALI. But what is L theta? This is cross entropy, that is minus log YL hat. So if we find out, we will get like this. I am not doing all the calculations that are not important for us. This is the dou L theta by dou A Li. Please remember, Li means I am taking only particular neuron. This neuron. We have K neurons, but I am interested only in one neuron till now. I have done only for one neuron because we have K neurons. AL1, L2, so on, LK we have. Okay. Now, so we know that the gradient with respect to vector AL. What is vector AL? L1, L2, so on, LK. It has got again K elements. So for to find out the gradient of vector, we take the individual partial derivatives like this. If you take like this, you get like this. And already, so this is the final answer. Okay. So now, as I told you, we have to find out the gradient with respect to output layer. So what you have done, if you remember properly, first we have found out gradient of Y cap and next gradient of AL. That is for output layer. So this is the activation, this is a pre-activation. So we can also find out gradient with respect to hidden layers. Okay. So we have to find out what? Gradient of HK and gradient of AK. Okay. HK and AK. What does it mean? All this. A1, H1, A2, H2. They are the hidden layers, right? And gradient with respect to the weights and biases. So we have so many weights and biases, right? We have to find out the gradient of all the weights. W1, W2, W3, B1, B2, B3. So if you do all these things, that is the end of the back propagation using gradient descent. we update the weights using gradient descent logic or algorithm. Okay, so here, so if you take the so how to apply chain rule for a multipath network. Suppose you take this network. Okay, now this is Z, this is y1 equal to x square, this is y2 equal to x cube, this is x. Okay, so there are multiple paths from input to output. Clear? So if I ask you how to find dou z by dou x, what do you do? How to find dou z by dou x? What do? You have two paths, right? So this part plus this part, and remaining part is what? Like this. So what do you write? What is the answer? What do you write now? Dou z by dou y1, dou y1 by dou x plus dou z by dou y2 and dou y2 by dou x. So the answer is, for this the answer is dou z by dou y1 into dou y1 by dou x plus, it is for one path. What path? This part. Remaining part, so dou z by, so this is how we deal with the multipaths. Already we have done this in the problem also. In the problem also there are multiple paths, right? So here in this example, yeah, so from this to this, how to get it from this to this? Multiple paths, right? So in that case you have to add the chain rule. Okay, so what happens is, in the chain rule, so we need to find out the derivative of the activation functions. Okay, so logistic function and tan function. So this is the logistic function, that is 1 by 1 plus e power minus z. If you take the derivative, you get like this. If you take the tan h function, you get the derivative, you get like this. These are required, you must know this, because they will be useful in the chain rule. Okay, why? Because here actually I did not write the expressions for all these things. I only written expression for this first quantity. What is that? This quantity. We have done gradient with respect to the output vector only, but anyway you have to find out the gradient with respect to the hidden units, and at the same time with respect to the weights and biases. If you do all those things, you need to have a derivative of the activation functions. That's why I'm telling all these things. I'm telling you all these things. You must know this. You must know this also. In fact, you must know derivative of all the activation functions that you are using. Okay. So this is the simple chain rule using gradient descent. Sorry, this is a gradient descent using chain rule. Okay. So with this we complete the chain rule. So please try to solve some problems from any textbook. Okay. Thank you.